Okay, so for my video, I've decided to do a limiting reagent problem, and I feel like I'm pretty good at it, so that's why I've chosen this. So our problem is 3.25 grams of ammonia reacts with 3.5 grams of oxygen to form nitric oxide in water. So first we're going to write the balanced chemical formula, and then we are going to solve for the limiting reagent, and then after that we'll solve for how much excess reagent is left over after the reaction is completed. So to begin with A, our balanced chemical formula is for ammonia, and then we have 5 oxygen, and then that becomes 4 nitric oxide plus 6 water. Okay, so to solve for which the limiting reactant is, we have to figure out how much of nitric oxide we can make with both of these. So in red for ammonia, we'll begin, so NH3. Okay, so we want to start with the grams, so we have 3.25 grams of ammonia. And then the molar or molecular mass for ammonia is 17.031 grams. So this right here will give us the moles. And then to get over to the nitric oxide, we want to do a mole-to-mole ratio. So we will do 4 moles on top for the nitric oxide, and then 4 moles on the bottom for the ammonia. And then to complete that, we will multiply by the molecular mass of nitric oxide, which is 30.01 grams per 1 mole. So when you calculate that out, you get 5.72 grams of nitric oxide. Okay, so now we're going to do the same exact thing except for the oxygen. So O2. So we start with 3.5 grams of the oxygen, and then to find the amount of moles that we need, we do 1 over the molecular mass, which is 32 grams per mole. And then we're going to do the same thing with the mole-to-mole ratio of nitric oxide to oxygen. So 4 moles over 5 moles. And then once again, we will do the molecular mass of nitric oxide to figure out how much nitric oxide we can make for the given amount of water. So when we solve that out on the calculator, we get 2.63 grams of nitric oxide. So because the oxygen provides less or a smaller mass of nitric oxide after the reaction, we know that the oxygen is the limiting reactant and that the ammonia will be in excess. So O2 is the limiting. So now on to C. I'll switch back to black. We now need to figure out the amount of excess reagent that's left over. So to do this, we basically work backwards from on the NH3 to nitric oxide. So we're going to go from this amount of nitric oxide that we were able to make with the oxygen, but we're going to solve this equation backwards and end with the molecular mass of ammonia, and that's how much is left over after we subtract from the total amount. So in green, let's start with 2.63 grams of nitric oxide, and we're going to multiply that by its 1 over its molecular mass, which is 30.01 grams. And then since that gives us the moles, we're going to do the mole-to-mole ratio from nitric oxide to ammonia. So we do 4 moles over 4 moles, because 4 to 4. And then we'll end with the molecular mass of ammonia. So that is 17.031 grams over 1 mole. So this is basically, this equation worked backwards. So then when you solve that, it gives you 1.49 grams of ammonia. We're not done yet though, because now that we have that amount, we have to go back to the top amount, which is 3.25 grams of NH3. for ammonia, and we have to subtract this amount from it. So when you do that, you end up with 1.76 grams of NH3 in excess. And that's about it.